Hey, long time no see. We're catching up on some old PDP Camp videos from the summer that we haven't posted, and there's sort of a jump in the narrative, and so I thought I would fill in with a little bit of an introduction. In the previous videos, we've been trying to track down this problem where the number 3 bit in the MQ, or multiplier quotient, wasn't being lit up the way that it should be in some tests, diagnostics that we were running relating to the tape drive. Dawson and Julian thought they had fixed the problem by doing some things, switching some cards around, which can often resolve issues where there's dust or oxidation or some kind of problem on the flip chip edge connectors. And it seemed like that fixed the problem. So in the previous short video that I posted, they were sort of celebrating and showing off they also realized the teletype bell was the error sound they were hearing, and so it was sort of a yay, declare victory moment. Turns out the problem came back, and so this is where the next video is going to pick up, is with me demonstrating that the problem's back, it wasn't actually fixed, and what you're going to see is that we try to solve the problem, or at least identify the problem, by looking at the flip chips that hold the multiplier quotient bits. So there's 6 flip chips. Each of them hold, I believe, 2 bits of the multiplier quotient. Could be wrong on the exact number there. Watch the video to find out. And so we think, oh, well, what if we flip the bits around in the multiplier quotient? Will we see the missing bit also move around? That would indicate a problem with the hardware that's implementing each bit of that register. So we'll just have to see what happens, and I hope you enjoy the next set of videos. Welcome back to PDP Camp. Right now, Dawson is over here working on the flip chip tester. We're going to do some modifications so we can hopefully access it via USB. And Julian is about to start swapping the M222 cards. So we've moved, or we've labeled them rather. These are the cards that include the accumulator for the tape drive. We tried the other tape drive and we get the same error in the accumulator. So what we're going to try to do is move the card that has bit 3 of the accumulator, which is the only bit that's dark, after our test. And so we're going to see if that changes the result that we get. So we're trying to rule out, is it the accumulator that's the problem? Is it something that's feeding the accumulator, or something downstream from the accumulator? So that's what we're going to do right now. All right, we'll see you soon. All right, now we're back, and we've moved 2 of the tape register cards. So you see, we labeled these in order. It shouldn't really matter, but we just wanted to, you know, for our own purposes. So we've flipped 1 and 2 here, and you notice we kept having this black bit in the multiplier quotient in bit 0123, and that should be on in this slot where 2 is now, but 1 was before. So now we're going to go over here, and got the tape loaded, and Julian is going to run the test, and we'll see what happens. So that's very interesting, because it seems like the tests are running. We've never had quite this response before. So that's suggesting that there really is a problem with those cards. But let's see what happens. It should stop upon a failure. Aha! So we have a new stop value, which looks like 1777 in the memory address, and in the accumulator we have 0773 and nothing in the multiplier quotient. So we've never had this situation happen before. So I'm going to let Julian look at the source code and figure out if this is an error or if this is success, since this program doesn't actually print anything. So stay tuned for more information. And of course, the next thing we'll probably want to do, depending on what we discover, is at some point we might want to switch these cards back and see if we have the same error. So debugging old hardware is always fun. Stay tuned. Alright, so Julian is looking at the listing, seeing what success should be, but one of the features of this test program is that we can change the input patterns that it uses for testing. And so if you look over here on our messy whiteboard, if sense switch 4 is set to 0, it uses a fixed pattern based on the left and right switches. So I'm going to set the left and right switches to a pattern. I'm going to try all ones. That's done something weird before. It's been sort of a weird case. So I'm not actually sure that all ones is going to work, and we'll see what happens. But I'm going to rerun the test now, and we'll see what happens. Ah, okay. Interesting. So we reran the test, and what we get is that same error from before. So bit 3 is dark in the MQ, and we have 1276, which is the address of the error that we've been hunting down. So that is very unusual. I'm going to stop. I'm going to change this pattern back. And let's see if this works again. Okay, so I literally just changed the switches back to where they were, zeros all the way across, and we've got the same error again, 1276. So that's very weird. I'm going to stop, IO preset, start. I'm going to make sure these are all down, and now I'm going to try it again. Same thing. Okay, let's try a different pattern. Same thing. Same thing. So 1, 2, 3, 4. I'm going to set 4, and that uses a random pattern based on the switch input. Let's see if that changes anything. No, same thing. So curiouser and curiouser, the success that we seem to have, which you and I both saw, seems to have disappeared. Okay, so I'm gonna maybe have, well, Julian and I will talk about it, and we'll try something else. So stay tuned.